Section 11.2 is going to deal with series, and this is closely related to limits that we did in 11.1. So you're going to need your calculator for a lot of different things. Back in chapter 10, we learned that a series is the sum of the numbers in a sequence. However, most of what we did was finite series. We didn't really do infinite series because all of our sums had specific sets of numbers. For instance, when you look at this problem right here, it's telling you to go from 1 to 100, meaning you're only finding the sum of 100 numbers. It's not infinite, it's not forever. And so let's think about infinite series for a second. So if you have infinite, that means it continues on without end. So let's say this first one here, you've got 1 plus 2, 3, 4, 5, 6, so forth. This implies that it's infinite because of the dot, dot, dot. But also look at your numbers. Notice that they're all increasing. So if I were to say to you, find the sum of this infinite series, how can you find one sum if your values are continually increasing? We could find the sum of 1 through 6 right here, but then if we add 7, that's going to increase, and if we add 8, that's going to increase, and add 9. So how do you find the sum? Can we actually do this? Let's look at the second one. Now you've got 32 plus 16 plus 8 plus 4 plus 2 plus 1 plus 1/2 plus 1/4 and so on. So again, dot, 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 this is an infinite series. Notice that, look, if you look at your numbers, notice what's happening. You're taking half of every number. If you were to take half of every number, eventually you're going to get really close to 0. And you can try that on the calculator if you just keep dividing by 2. You're going to get close to 0. Eventually your calculator may even say 0. Therefore, what's the limit? The limit is 0 because that's what it's getting close to. So there are two words that we use to describe these types of series. For this first one, we call it divergent. Think of it like diverge means to go away, meaning it's not getting close to one thing. It's divergent specifically because there's no limit. There is no limit to this function, it just keeps increasing. Therefore, there would be no sum to that series. For the second one, we would say that this is convergent because the limit is 0. If you keep taking half, if you keep dividing by 2, you'll eventually get to 0. And then if you're just adding 0, nothing's going to change, so there will be a definite sum. Now, the only type of series that we can find the entire sum of is a geometric sequence where the absolute value of r is less than 1. So here's what that means. Notice that this is the explicit formula for a geometric sequence. A sub 1 is your first term. R is the ratio that you're multiplying by. So when it says the absolute value of r is less than 1, that means that we're talking about a fraction between 0 and 1. So notice how it's set up. It says to do n equals 1 to infinity. It also says that this is equal to a sub 1 over 1 minus r. So here's what this is telling us. You could do this on the calculator, which would be the part to the left, or you can use a formula, which is the part to the right. I personally like the formula better just because on the calculator you have to do more steps, especially on my calculator, the older model, it gets a little tricky. Because the older calculator is just tricky in general, but even for the new one, you can't put infinity into your summation. So let's look down here. So I'm going to show you an example, and I'll show you both ways of doing it, and I've included some screenshots of the calculator. I am using the newer model calculator. I have Emma's calculator, so just FYI. So let's say that you are asked to evaluate this sum. Notice that it's going from 1 to infinity. Well, the only way we can do this is if the limit is 0. So let's take a look, or if we follow the rule that was stated above. When you look at this, notice this is like the explicit formula. So what is in place of the r? That's the 1/2. Is that less than 1? Yes. So since the absolute value of r has to be less than 1, we're going to be able to find the sum. Now, if we want to use the formula, we're going to have to plug in 1 into the equation so that we can get the first term. So if we substitute 1 for the n value, remember 1 minus 1 is 0, so anything to the 0 power is 1, times 3 is 3. So according to the formula, you would put 3 over 1 minus 1/2, and that's going to give you 6. Now, on the calculator, when you do your two summations, what you have to do is you have to do one of them with a high number of 100, and then do a second one with a high number of 200. If the sums are the same, then that's the sum, meaning if you add 100 numbers, but then you add 200 numbers and nothing changes, then that's going to be the sum. But if the sums aren't the same, there's going to be no sum. So I'm going to try and show you examples of all that. So let's look at the calculator here. So I did a summation from 1 to 100 and got 6. I did a summation from 1 to 200 and got 6. Therefore, 6 is our sum, just like we got when we did with the formula back here. Also, for some of you, just take note of how this is being entered into the calculator, because I think this is where some of you are messing up in terms of where parentheses and exponents and things are. Just be careful about how you enter things. All right. So again, this is going to be closely related to limits. If your limit is not 0, there's no infinite sum. So look at page 552. I'm going to do some examples out of your book. And again, I've tried to show you some screenshots of some things that I've done here, and I'll explain it. First thing you could do is you could do the two summations. So look over here to the right. I did the summation from 1 to 100, did the summation from 1 to 200, but notice that the sums are not the same. That means there is no sum to this infinite series. Also take note of how I entered it into the calculator, just as an FYI. Now, if you take that same 3x over 2x minus 5, if we had put that into our y equals, if you go to your table and you put in really big x numbers, so this is what I put in, look at the y's, they're getting close to 1.5. That means that's the limit. The limit is 1.5. But if the limit's not 0, there is no sum, which we confirmed over here as well. The two sums are not the same. Let's look at number 2. If you put the function for number 2 into your y equals and then you go to your table, my x values are still the same. I didn't change that. Look at the y values. This is the limit. They're all the same. The limit is 0.1429, but it's not 0, so there's no sum. How about number 4? If you put that into your y equals, notice that your limit is 4. Still no sum. And notice I'm not changing the x's, just leave them. 14. There's not even a limit here, because what this is showing is that when you put this function in and you put in big x values, your y's are going to keep getting bigger and bigger and bigger. Therefore, there's no limit, so no sum. And of course, you could be doing summations on all these, but I think this is easier. Now on 15, notice that if we put that function in, we keep our x's big. Look at the limit. The limit is 0, which means we could find this sum. And you can find that sum either using the formula or putting it into your calculator and doing the summation to 100 and 200 to see that they're equal. So for your homework on 555, you're going to do 7 through 13. All you are doing is finding the sum. If you can't, then you write no sum. So don't worry about the instructions in the book, just find the sum. And if you can't, if there's no sum, then write no sum.